you. So I'm passionate about fashion, but I'm also a science fiction fan, like Sean says. So I walk into a newsagent with the intention of buying Vogue, and usually I'm walking back out with a bunch of fashion magazines and a copy of The New Scientist. And I guess this kind of got me into, this kind of behavior led me to the point where I ended up writing a book about the future of fashion and new technology. And part of that research actually involved me going around asking people from many different disciplines the same question, essentially, what do you think fashion will look like in 50 years' time? It's a method a scientific method that I like to describe as this. One of the people that I spoke to was a biologist. And actually he said to me, you know, the way we've been doing things for hundreds of years, the whole kind of growing a plant, weaving a fibre, using sewing machines, you can rethink that whole thing in one go. We could grow a dress in a laboratory. And so that started a whole dialogue, which has since become my journey. It's how to turn silly into sensible. So I was presented with this vision. We could grow a dress in a laboratory. My first thoughts were, how on earth do you do that? And what the hell does it look like? And it really kind of took me to a place where I started to engage with engineers and scientists, I guess. And this particular biologist, I said, well, you know, how do we go about doing that? And can you show me? Let's see if we can make that happen. The why we would want to do that sort of came later. So the first step for me in this journey was about disruption in thinking. It was about finding reading matter that I wouldn't, you know, being drawn to read about science and technology, discovering ideas that I had never been exposed to, and then going to talk to people I would never normally have met. Fashion designers don't tend to surround themselves with engineers and scientists. So this first stage was about seeking out expertise and having dialogue with people who spoke a completely different language to me. I didn't even understand what they were saying to begin with, because we had a very empirical scientific language being counteracted with something that was completely intuitive and creative. But anyway, we kind of muddled through, and what came out of it was, you know, my imagination really being sparked and people throwing things at me that completely challenged and undermined everything I had ever thought about the way I had done things. And so this led to this new direction, which is the project that I've been working on ever since. Essentially, overnight, I went from working with this, which was familiar to me, to this. And now maybe you can see why buying The New Scientist instead of Vogue got me into trouble. This is obviously not so glamorous, completely takes me into another world. And essentially, we started to have this very informal conversation turned into a challenge where myself and the biologist said, okay, well, let's just see what happens if we get together. Let's see what we can produce. So it started with using a microorganism and looking at the way a microorganism can actually spin threads of cellulose as a waste material, but how that might then be able to be used to create a cloth or a material for fashion and textiles. And so actually what we do is we use a kombucha-style recipe, and this is a symbiotic mix of yeasts, bacteria, and other microorganisms. And what they're doing is here they're being implanted into a sugary green tea solution, and as the bacteria, the microorganisms, feed on the sugar, they are spinning a thread, and these little tiny microfibrils of cellulose stick together and they start to form layers. The layers eventually come through the liquid and form a mat on the surface. It's the byproduct of fermentation, essentially. So it's a waste material. And that's what we're using to harvest. So as you can see, the tools of my trade have changed somewhat from a fashion atelier. I start now by brewing litres of green tea, adding a couple of kilos of sugar, and then once it's cooled to below 30 degrees C, it goes into a growth bath. The growth bath is sitting on a heat mat which has a sensor and a thermostat to control the temperature 24/7. And then the mother culture, this microorganism that you see here, is sitting there. That's added along with some acetic acid. And we start to grow the material. In the summer, actually, I have a little mini fabric farm outside my studio. And this is the process as it's happening. So the bath on the left is what it looks like after 5 days, and on the right after 10. So it's growing this skin. It doesn't need light. And when you're ready to harvest it, this delightful substance, you remove it from the bath, you wash it in cold soapy water, and you can just leave it at that phase. But what actually you have is something which is over 90% water. So it's super heavy. It's really absorbent. So I spread it out onto a wooden sheet and let the evaporation take place. And as it does so, the fibers are really compacting. And what you end up with is something that, depending on the recipe you've used, can be either like a very transparent paper or something which is much more like a vegetable leather. So that can then be taken and cut out into garment shapes and still sewn conventionally. Or you can use the wet material to form it around three-dimensional shapes. So actually here we had to start to kind of rethink the tools that we were using to create clothing. So instead of a traditional tailor's dummy, which would be a vacuum-formed thing with a padded fabric cover, obviously you couldn't put a load of heavy wet material onto that. So we built a wooden dress form, which is completely articulated. The whole thing can come apart. And then the wet material is placed onto that form. And as it dries, what it's doing is it's knitting itself together. So those fibers are actually forming extremely strong seams. So this is just the sort of first kind of prototype, and that was the finished dress. So it's sort of had nothing done to it. It's completely grown with a microorganism, could potentially come from a waste sugar stream. So something which has come from, for example, the food or drinks industry, and they're pumping out a waste sugar water stream, could be used to power it. This one has no stitching at all, so the whole thing has kind of formed itself. And, we were going along and thinking, okay, yes, we're beginning to understand what we're doing here. And then, of course, inevitably, things go wrong. So this was one where I was really trying to see how far we could stretch the material over a shape. And I don't know if you can see, but I'd pinned the wet material down, and I'd used metal pins on the board. And in fact, when I came back to see if it was dry, what had happened was the metal had turned the material black. I thought, oh God, it's a disaster. This is not, that's not what I wanted it to happen. And then I thought about it, and I realized, actually, well, what I've done is I've turned it black without using any pigment, without using any dye. So I've actually jumped a process. If I wanted to turn it black, I found a way of doing it without extra chemicals. So just by oxidation, we discovered a technique. So then we thought, well, how do we use that kind of disaster and turn it into something? So this was looking at how we can then take that and start to create studied patterns on our wooden board, so that now when we put the wet material on, we get a kind of eco-patterning effect without using any chemicals or dye. So we explored that, and that led to our veggie biker jacket. These are concept garments. This is not on the market. These are still very experimental. They're exploring the ideas. But so that was kind of the first one. So looking at the idea of like a black leather iconic jacket, which would have had studded metal in it, and kind of flipping it and just doing a sort of negative of that. So instead of the studded metal, we used the studded metal in the sheets. And then what they left was like their shadow behind in the black. And then we thought, okay, well, so that was using an accident and turning it into a positive, but it was unintentional. What happens if we intentionally think about a similar kind of process? And we thought, well, when you throw beetroot down a white shirt, it's really difficult to get the stain out. So you've forced colour into something, and it might not be desirable. What happens if we actually try and use staining as an idea? So then we started playing around with all kinds of fruit and vegetable pulps, and because the material is so absorbent, it stained really well. So then we produced some laser cut stencils, and we filled it with the fruit and vegetable stains, which again is like just a waste pulp, and looked at making a kind of eco-patterning using staining. So that was a sort of intentional version of using a disruptive process, I guess. And then this last example, this was modeled around the idea of a sort of jean-style jacket. So actually this whole garment was hand-sewn, and the color is coming from the green tea, but then it was garment dyed in an indigo vat. And when you dye cotton or a natural fiber, for denim jeans or a jacket, you normally have to dip it up to 18 times to achieve a really dark indigo. And in fact, what we discovered with this bacterial cellulose as opposed to plant-based cellulose is because of its super absorbency, it only needed one dip. And that dip could be very, very short. So the amount of dye and chemicals that it was using were absolutely minimal by comparison to a traditional plant-based fiber. So that was really encouraging. And actually, there was a secondary benefit which we didn't know about, which is that indigo is also a natural preservative of cellulose fibers. So actually, it prevents any attack on the fiber from other microorganisms. So in the long run, it actually extends the life of the material. So it's a natural antimicrobial kind of finish to the garment. So that's the final version of that jacket. These are still really kind of concept pieces. They're not wearable, and even though I'm wearing one today, it's not stable. So you're welcome to come up and have a feel. I've got some swatches with me. But I think what emerged out of the process was that, this started just as a kind of a really informal conversation with someone, talking about the future, no real kind of specific context for it. So these are the sort of stages, it was like having conversations with people, coming up with crazy theories, not necessarily having a clear context, but then starting to play, and actually through those playful methods, realizing that what we were doing was actually addressing a lot of the other stuff that was being talked about in terms of the fashion and textile industry, which are rapidly rising commodity prices, vast quantities of really harmful pesticides and chemicals being used in the processing of the materials, fast fashion producing mountains of toxic clothing that just goes straight to landfill. And all this stuff was happening at the same time. And then we realized, well, actually, what we're talking about here has all kinds of synergies with our industry, but actually all sorts of other areas of design and manufacture. What we're talking about is using potentially some kind of waste stream, adding an organism to it that just feeds on the waste, produces a material, which is a waste material, but could potentially be growing something useful for us that can then be biodegraded at the end of use. So the whole kind of process in the end actually started from just a simple disruptive thought, but sort of has really led to something. And actually, I now believe that it's sort of possibly not fashion that we're looking at here as the real kind of market for the material, because we've had so many kind of, interest has come from so many other industries. What I've learned, I guess, is that it's good to read strange matter. It's really good to meet people who you have no understanding about, who speak a different language, and to really try and communicate with them. And to really embrace those accidents, because they can be really informative. And I think that's also what's great about TED as well, is that you're in a room full of people who come from such different backgrounds, and it's actually really rewarding to go and talk to the people that you wouldn't ordinarily have an encounter with. For me, I think maybe that helps explain why a fashion designer sort of asks a question and ends up growing frocks from bacteria. But thank you, and thank you for sharing in that journey with me.